Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to explain you the concept of multiple key access on B plus tree index files. Multiple key access on B plus tree index files. So what is meant by indexing mechanism? So to search and to retrieve the records from the different databases, we are used to find out the records based on the indexes methods, based on indexing methods. So index methods contains a search keys as well as pointers. Index files maintains that both indexes as well as search keys and pointers. So the B plus tree indexes mechanism is also one such method to retrieve the data, to retrieve the records, to retrieve the data or to retrieve the records. So how the indexing mechanism, B plus tree indexing mechanism will work for to retrieve the records, to retrieve the records. So a B plus tree is a rooted tree. So which actually B plus tree contains the node structure, a node structure which follows, a node structure which follows. The node structure represents what? The pointer followed with the search key. Pointer followed with the search key. In the same way as pointer search followed with the search key 2. Pointer followed with the search key 3. So like that, the node structure of B plus tree index follows. So how the conditions will apply to make it as a B plus tree indexing mechanism. So in this, every root of the B plus tree index have same length, and each node that is not a root, or leaf has between n by 2 and n children, That means if the number of nodes are 6, then it has the leaf nodes are n by 2 and n children. So n by 2 is nothing but the 6 by 2, 3 roots are there. 3 roots for 6 children. 3 roots for 6 children. And a leaf node has between n minus 1 by 2, and n minus 1 values. So it may contains both n minus 1 by 2 nodes, or else it contains n minus 1 values. If the root is not a leaf, that means the root node is not a leaf node, That means a root node contains internal nodes contains as well as leaf nodes. So the structure follows what? Root node, and root node contains internal node. Internal node contains leaf nodes. So if the root is not a leaf, it has at least 2 children. If the root is a leaf, that means that doesn't have any child nodes. That indicates that what? There are no other nodes in the tree. Means there are no child nodes or internal nodes represented in that node structure. And it can have between 0 and n minus 1 values. Suppose if n is the number of 2, if n is the 2, then it contains n minus 1 values. That means only 2 minus 1, only 1 is the node. So like the way it satisfies the properties to follow the indexing mechanisms. So here the queries applying queries applying on B trees. How the queries are applying on B plus tree indexes. So here the query inserts with find record with search key value V. So find the records. So how the records are going to be retrieved based on the search key value. So for that, the query which will process the algorithm is like this way. So initially C equals to root. initially c equals to root. That means the root is the child or root is the leaf node, where C is not a leaf node. So consider that where C is not a leaf node. So C is the root node, and if root node is not a leaf node, let I be the least value. Let I be least value so that V less than or equals to Ki. V less than or equal to Ki. That means V is the search key value which is either first one or second one. Less than or equal to Ki. How many number of search keys are there? So if contains 5, then K5. If contains 4, then K4. So the second one is less than or equal to fourth one, or second one is less than or equal to 5, fifth one. If no such exist, if no such exist, C equals to last. C equals to last. A non-null pointer in C. Non-null pointer in C. So this is all if condition. This is all if condition while C is not a leaf node. While C is not a leaf node. Else, if V equals to Ki, if V equals to Ki means the search key value, the first search key value is equals to the 1, or else second search key value is equals to the 2, then set C equals to Pi plus 1. That means point incrementation of the pointer. Incrementation of the pointer. So that incrementing of the pointer, that means it indirectly pointed to the next pointer. Else set C equals to Pi. That means it points out the current node. It points out the current node. So set C equals to Pi. So this is the condition where C is a not leaf node, or C is a leaf node. C is not a leaf node as well as C is leaf node. Let I be the least value. Let I be the least value so that Ki equals to V. Ki equals to V. That means the number of values 2 equals to the second value V, the search key value V. So that equals to, if there is such value of I, that follow pointer Pi to the desired record. Pi to the desired record. Else no record with search key value K exists. Else no record with search key value K exists. So like the way if it takes the conditions on both, where root is the leaf node, then it finds out the incrementation of the pointers that leads to next record. If C is a leaf node, then it has to be incremented for the pointer and let it move to the next record for the search key values. So here similarly I will take the I value, and I value is also following pointer to the next values. Else no record with search key values are existed. So here this is the root node. This is the root node which contains either pointer, as well as search key value, which contains both pointer as well as search key value. So the pointer moves to pointing the next node, that is all these internal nodes level. So it pointed to the internal node which is already pointed to the leaf node. So this is all leaf nodes. So the root node pointer is pointed to the internal node pointer. Similarly, internal node pointer is pointed to the leaf node pointer. So like the way it pointed to the next pointer, and the search key is pointed to the next search key values. Search key is pointed to the next search key values. So this happens until the last record exists. It happens until the last record exists. If last record is found, then it displays with the last records. If the last record does not found, then it terminates the record not found. It terminates to display record not found. So this is the way actual algorithm workflow will happen in the B plus trees indexes. B plus tree indexes. And here some queries on B plus trees. If there are k search keys values in the file, if there are k search key values in the file, the height of the tree is no more than log k base n by 2. Log k base n by 2. And a node is generally the same size as disk block. A node is generally same size as disk block. Typically, it maintains what 4 kilobytes, and n is typically around 100. That indicates what 40 bytes per index entry. 40 bytes per index entry. With 1 million search key values, and n equals to 100. With 1 million search key values and n equals to 100. At most, log 50 of 1 lakh, 10 lakhs equals to 4 nodes are accessed in lookup. So contrast this with a balanced binary tree. With 1 million search key values, nearly 1 million search key values. Around 20 nodes are accessed in a lookup. That means that all indicates that what the number of nodes are increasing. Automatically the search key values to be found is to be increasing. So above, the difference is significant since every node access may need a disk input or output. That costing around 20 millisecond. So this is one type of query on B plus trees. On this multiple key access. So use multiple indices are nothing but indexes. Use multiple indexes for certain types of queries. So some sort of queries are there. So for example, select ID from instructor. Where department number equals to finance and salary equal to 80,000. So what I need to display? I want to display the IDs of the instructor. Where the department name equals to finance and the salary equals to 80,000. So possible strategies for processing query using indexes on single attributes. So this query is going to be converted into the different portions like lexical parsings, tokens, and after that it is converted into the low-level language relational queries. So for this, the keys are used to access the records. Either it uses ID as the accessing, as well as instructor department name is also accessing. So either ID is accessing or either department name is accessing. So multiple keys are going to be accessing the records. Multiple keys are used to accessing the records. So use index on department name. So here use index on department name to find instructors with department name finance and test salary 80,000. So what we need to create? We need to create an index with the name department name. Why we are creating an index for the department name? Because we are going to find the instructor IDs based on the department name equals to finance. So definitely we have to create an index. For department underscore name. And use index on salary. Create an index for salary also. So now we are creating multiple indexes so that multiple search keys are also available. So here for this one, the salary is one search key and the department underscore name is also one search key. Use department name index to find pointers to all records. all records pertaining to the finance department. So pointing all the records to pointing the department, finance department. And similarly, use index on salary. So that is what we mentioned here. Use index for department name and use index for salary. Now department name and salary nodes are pointing to the next department name and next to salary of the records. Next department name and next to salary of the departments. So like the way intersection of both sets of pointers is to be obtained. Both sets to be obtained. So how that indices on multiple keys, will be applied. So composite search keys. So composite search keys are nothing but what? The number of group of the keys. Group of the keys are group of the search keys are presented. So here we already mentioned that what? Create an index for department underscore name is 1 and index for salary is 1. So composite search keys are search keys containing more than one attribute. So example, department name and salary. This is the composite search key. So this lexicography ordering. So lexicography ordering is what? So it contains A1, A2 less than or equals to or less than equals to less than B1, B2. If either A1 should be less than B1 or else A1 equals to B1 or else A2 less than B2. A2 less than B2 because we are using the operator less than operator. So it contains what? Either A1 less than B1 or else A2 less than B2 or else A1 equals to B1. So on this condition it has to be searched. And indices on multiple attributes. So multiple attributes on indices. Suppose we have an index on combined search key. So this is the combined search key like department name, salary with the where clause. So where department name equals to finance. And salary equals to 80,000. Salary equals to 80,000. So the index on department name, salary can be used to fetch only the records that satisfies both conditions. So what we are going to retrieve here? We are going to retrieve the department IDs. Based on the condition what? Where department number equals to finance, where department name equals to finance and salary equals to 80,000. So those two conditions are to be true. As per the database dictionary, So using separate indexes is less efficient. We may fetch many records or pointers that satisfy only one of the conditions. So using separate indexes are nothing but here what? We are created an index for department name. We are created index for salary also. We are created index for department name, and we are created a index for salary. So using separate indexes is less efficient. We may fetch many records. Or pointers that satisfies only one of the conditions. It can also efficiently handle where department name equals to finance and the salary equals to 80,000. But cannot efficiently handle where department name less than finance and the balance equals to 80,000. So this condition never happen, but balance less than 80,000 condition will happen. So here this department name could not be pointed with the symbol operators less than, and it does not fetch the records based on this condition. And this may fetch many records that satisfies the first but not the second condition. second condition. So on basis of balance it is displayed, but on basis of this department name will not be work. Will not be work. So the order of the attributes matters here. The order of the attributes matter here. So this is indices on multiple attributes. This is the indices on multiple attributes. So how we are going to use these indexes on multiple attributes? So the composite search key, combined search key is helpful to fetching the records or retrieve the records on databases. So one, so this is the multiple attributes, indexes on multiple attributes. So once again we revise the topic which we discussed in this session. So generally what is meant by B plus tree, what is meant by B plus trees, and what mechanism, what indexing mechanism we are using here. So B plus tree index files, those are nothing but rooted trees that satisfies the following condition, What are those following conditions? The B plus tree indicates that what node structure which contains pointer as well as search key, and this tree contains what? One is root node, and the second one is internal node, and then third one is leaf node. It maintains what? Three types of nodes. One is root node, and the second one is internal node, and the third one is leaf node. So these three nodes follows the node structure B plus tree, and it follows some certain properties, like what? Each node that not a root, if it is having, if the root is in leaf condition, and if the root is in not leaf condition, or if the root is in not leaf condition. If the root is leaf condition, the leaf node is between n minus 1 by 2 and n minus 1 values. In what condition? If the root is in leaf condition. If the root is in leaf condition, it contains what? N minus 1 by 2 values and n minus 1 values. But if the root is not in leaf condition, it has at least two children, and it have between 0 and n minus 1 values. It have zeros and n minus 1 values. So that is the basic structure of this B plus tree index files. So node structure contains what? Root nodes, internal nodes, and leaf nodes, and it follows what? Pointer follows what? Search key follows what? Pointer follows what? Search key follows what? Pointer, and again pointer follows what? Search key. So the queries, so how the query is evaluated on algorithm basis. So to find the records with search key values, initially we are going to take a C equals to root. So we are performing this algorithm on basis of two conditions. Either root is a leaf condition and root is not a leaf condition. Root is a leaf condition and root is a not leaf condition. So if root is a leaf condition and root is a leaf condition, so C equals to root, while C is not a leaf node. Let I be the least value. So that V less than or equal to Ki. That means the search key value is less than that number of search key values. The presenting search key value, which V is the number of less than that of search key values entire. So V less than or equals to Ki. So it be increasing with the pointers, where C equals to Pi plus 1, where P equals to C equals to Pi plus 1. So at that moment it is increasing where C equals to P1 or P2 or P3, and let I be the least value, so that Ki equals to V. So at that moment that search key values, the position of the search key value is equals to the count of the search key values. So if there is a search values, it follows pointer pi, it follows pointer pi to the desired record, to the desired record. Else it does not having any records, it does not having any record. So it with such key values that such key values the record existed. So here the diagrammatically that algorithms performs the root structure, root node here. The root node follows both pointer as well as search key. The pointer of the root node pointed to the pointed to the next pointer of the internal node. And similarly, the pointer of the internal node is pointed to the pointer of the leaf node. Pointed of the leaf node. So at that moment it points it forward to the it forwards the record, it forwards the pointer to find out that particular record. So if the record is found, if the last record is found, then it displays. If the last record is not displayed, then the record is not found, it displays the record is not found. And here the query is how many number of nodes are presented for the number of search key values. How many number of nodes were presented for search key values. How many number of nodes were presented here for search key values. So here the number of nodes is equals to 4 and number of nodes is equal to around takes 20 nodes or 4 nodes for if n equals to 100, then it displays the number of values and number of records are going to be displayed. And multiple key access, so number of using multiple keys, using multiple search keys, for retrieving the data on behalf of each and every column name. So here take an example to display the select ID, to select ID from the customer, from the instructor, select ID from instructor where department name equals to finance and salary equals to 80,000. So here the ID is the primary index and department name is the secondary index. So ID is taken as a primary index and the department name is taken as a secondary index. Based on that indexes, the index search key is going to be find the record on basis of this condition. On what condition? Where department name equals to finance and the salary equals to 80,000. So here the uses, we have to create the index for what? Index for department name and the index for salary. So that the indexes created for the salary and department name will find out the records on basis of the salary equal to 80,000 and the department name equals to finance. The searching mechanism improves the access time so that within span of seconds the department name equals to finance will be displayed and the salary also 80,000 will be displayed. So here the search keys are both indexing keys. What are those? Department name and salary. So use department name index to find pointers to all records. Similarly, use index on salary. Take intersection of both sets of and pointers to be obtained. And indices on multiple keys. So composite search keys. So department name, salaries. So creating multiple indexes for the columns, that is nothing but composite search key. Composite search key means the number of search keys are used to find out the records for the search key values. And indices on multiple attributes. So how we are going to retrieve the values on basis of this combined search key. So the combined search key is what? Department name, salary. Department name, salary is the combined search key. So with the where class. So in the where class, the department name equals to finance. And the salary equals to 80,000. So as we created an index for the department name and an index for the salary, it finds out and it retrieves the records only based on salary and only based on department name, only based on salary and only based on department name. So it fetches the record to be found on finance and a salary 80,000. So now it can efficiently handle on this condition. On what condition? Where department name equals to finance and salary less than 80 condition. It satisfies. It satisfies and it can efficiently handle. But department name less than finance and balance equal to 80,000 could not be handled efficiently handled, because the department name less than finance will not work out. Will not work out. So it may fetch many records. It may fetch many records that satisfy the first one, that satisfies this first one, but not the second condition. That not the second condition. So this is the way of creating an index, is creating multiple indexes to retrieve the data based on the combined search key values. Based on the combined search key value. So this is the multiple key access mechanisms, key accessing methods on B plus tree index files. So this is about all multiple key accesses, combined search keys on indexes, and multiple attributes on indexes. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.